So when you are.
Yeah, okay. So hi, good morning, everybody, and welcome to day 3 of the Summer Institute. I'm Mike Deutsch, and I'm KCJ's Director of Learning Services, and I am super excited to be able to talk to you all together. Um, the session we're about to do is one that I've done in a couple of different contexts, but never with people who know KCJ and who know our style of teaching and who really get where we're going. I often bring this to conferences of teachers who have very little experience with coding, and I sometimes bring it to conferences where coding is the thing, and where what I'm adding is the teaching side. Um, so I think it's going to be really fun to go through this together with you because you bring such a blend of the two. That's really what this week is all about. It's coding, yes, but teaching. So this is going to fit perfectly in the conversations that we've already been having. I'm having trouble seeing the chat pop up while I have my share going. So Zoe, I'm going to ask you just to keep me apprised if there are any questions. And I invite questions all throughout. We're going to have lots of opportunities to participate here after I get through the preliminaries. So keep your fingers on the keyboards. We'd love to have questions all the way through. And I think we can start. So just to give you an idea of what this session is going to be about, it's listed as the keynote, but this is not a lecture style session. And it's also a little bit different from the workshops that you've been doing in the other time slots. So here in this hour, I'm not going to teach you any new programming platforms or tools. I'm not going to introduce you to Python or JavaScript or microbits or Scratch or AI. I'm not going to supply you with new projects that you can do yourself or with your students. What I am going to do is introduce you to the way we like to open up new coding concepts and projects with a teaching routine. We're going to show you it's not the way we do everything, but increasingly it's the way we like to start new things to get off on a nice foot. So what I really want you to come away with is the feeling of how teaching a coding lesson this way opens up access for every student in the room and how it helps to build very flexible strategy setting, which is a super important thing when you're learning to code. Okay, so here's basically the rundown of what to expect. We're going to try this instructional routine together. I'll be leading and I'll ask you to participate as actively as you feel like, given whether your coffee's kicked in or not. We're going to do that in 3 different projects, a Scratch project, a JavaScript project, and then last, it's going to be a bit of a wild card. I'll open it up to suggestions and requests. We're going to bounce back and forth between doing the routine in a participatory way and then me explaining the ideas and the intent behind this routine and how we arrived at this as a tool in our tool belt. And then lastly, I want to have some discussion about how you might put this into practice in your classroom if you feel this is something you want to take on. I suspect, given the experience level of our teachers here, this is going to be a little bit familiar. Maybe it's something you've seen in a very different context, in a different subject. And we'll see how it goes here. Okay, a little bit. I'm coming to you from Jojaga, Montreal. The Ganyangahaga people are the traditional custodians of this region. I myself am a settler twice over. My people came from the old country in Central and Eastern Europe and arrived in the US where I grew up. And I've been living in Canada now for 21 years. I'm our Director of Learning Services, which means that in my department of KCJ, all of our development of materials happens, our selection of platforms and tools, and also our instruction. We just reorganized our teams a little bit, so that's new inside my team. All of the instructors that you've been meeting now belong to our team. I have a little bit of a career journey, the way Kate did in her opening keynote, and the way Matt presented yesterday in his keynote. And I'd like to share just a little bit. So I graduated with a bachelor's in computer science in Philadelphia at UPenn. I might be among the worst programmers that ever graduated from that computer science program. I never felt like I was being taught very well. I was being left to sink or swim on my own without a lot of support, particularly without a lot of understanding and pedagogical support. And I will tell you that made an impression on me. So I worked for about 20 years in the professional world, building software, managing different types of projects, and being a product manager. And for many years, I was sort of adjacent to education. I worked for 12 years at McGill behind the scenes in their IT department. I worked at a consulting company very early in my career where we consulted by learning, essentially. We did customized learning. And I also worked at Seymour Papert's old software company just by sheer luck. That was my first job when I moved to Montreal in 2000. And they're still around today, the company that made Logo and its descendants into commercial software. So I've always been in and around education, but it was only in 2014 when I met Kate and Juliet and found out about KCJ. Boy, that came just at the right time. I was starting to teach my own kids coding because I remembered the excitement of it when I was a kid. I was watching my kids grow up. My oldest was 8 at the time, and I started to teach her Scratch. And then just at the time when I was looking for more like that, I found Kate and Juliet in one of their open calls for corporate volunteers. And our setup at the time was they would create a lesson plan, put it in our hands, me as a volunteer. I would take time out of my workday, and they'd say, show up at this elementary school every Tuesday for the next 5 weeks. We've set you up with a class, and I would teach that way. And I was just smitten. I tried progressively to get more and more involved as a volunteer with KCJ. I also applied to and got into an MA education program at McGill, which I'm still this close to finishing. So this has been a career pivot for me, and I just love it. The kind of work that we get to do every day, it's a real treat, and I feel very fortunate to be contributing to it. You'll see my Twitter handle below my photo there, mdeutschmtl. I am by no means a big deal on Twitter. I'm very small, and I follow many more people than follow me. But I've found Twitter and teacher Twitter, education Twitter specifically, to be a great place to get involved in conversations, like real good conversations. So I invite you to connect with me, and I look forward to talking to you there. While I have the floor, you've seen the rundown of KCJ's other programs. I just wanted to share with you very briefly something that friends of ours are doing, and we're going to help them support for this year. The Aspirations in Computing Award is done by Can Quick. We're the Canadian affiliates of NCWIT. This is Women in Technology in the US and Celebration of Women in Computing in Canada. And I just wanted to bring this to your attention. They run an annual campaign for high school girls, anyone who identifies as a girl at the high school age. And it's a very simple application process just to declare what your interest is in computing as a career, and then give recognition and awards to girls who do that. So they're about to open that campaign September 1st to November 5th. If any of you are teachers at the high school level or are connected to girls at the high school level, we invite you to check that out. Okay. So now we're actually going to open with a participatory routine. I'm going to give myself a time check. We're 12 minutes in. Okay. So before I do, let me ask and answer in the chat. Are any of you familiar with the notion of an instructional routine? Is that a term that means anything to you? Type in the chat if that's something that you're familiar with. I want to see if that's completely new or if there's some familiarity.
We've got some yeses in the chat from Elizabeth, Marion, and Colleen. And we've got some people saying maybe, and also that it's brand new.
Okay. Terrific. So an instructional routine, this is something that I've studied in my master's program at McGill. So through that program, I have sort of one foot in the teacher education world. This is a McGill program that turns teachers into teacher educators, right? People who are behind the scenes developing, cultivating young teachers and teachers in their careers. So I have one foot in that world, and they also talk about research in the teaching profession, and research in math primarily, and computer science education. So that's where I got the notion of an instructional routine. An instructional routine, as I understand it, just a thumbnail version, is a way that you as a teacher introduce a new topic. The way you put something on the board, the way you read out instructions for a new thing you're about to do, to have a repertoire of routines like that, where the structure is the same each time, and so your students get used to the same structure every time you introduce something new, and gradually the structure starts to fade into the background. Your students become used to how you want them to interact, how you want them to participate, so that it doesn't feel like a cold new surprise. Okay, class, what I want you to do is, you develop a routine that you can lean on, and maybe an array of routines that you can use for different subjects that might work differently. Okay, so I'm about to do an instructional routine that some of you may have seen. It's often called Notice and Wonder. Can I just ask in the chat, does anybody know the Notice and Wonder routine?
Somebody literally just said that. Donna Kipta said, See, Think, Wonder is one of them, just before he said that.
Awesome. See, Think, Wonder I've seen, I think, in arts. Notice and Wonder I got from the math community. And there are like serious devotees of Notice and Wonder. And there are entire websites where you can find Notice and Wonder activities. So I'm going to flip over to this tab. Can I have a verbal confirmation that you're now seeing something new on my screen?
Yes, I'm seeing a maze.
Ah, okay. You are indeed seeing a maze. And the way I'm going to do this Notice and Wonder routine, ordinarily in a classroom, I would, if this were a math class or an art class, I would just put something up on the board for you to observe. And I would ask you, okay, this thing I've put in front of you, what do you notice here? And that's meant in the simplest possible sense. What do you notice? Meaning, like, just use your eyes. In a physical classroom, I would invite you to poke and prod and maybe try things. But here, because we're virtual, I'm going to ask you, what do you notice through the screen? And then the second question is, what do you wonder? Because you can't poke and prod this, I want you to ask me to try things, to explore things, nose around, and get at the things you're wondering about. For example, you might notice a screen just popped up. Actually, let me stop there, and I'll actually ask you the question. This is a project. Let's imagine that we're about to start building this, but I open with a Notice and Wonder, and I ask you, as I'm asking you right now, what do you notice? Hands on keyboards. Let's hear in the chat, what are some things you notice?
We got some responses so far, Mike. So Elizabeth is saying, yes, number of talks and Notice and Wonder are the first
Number talks,
thing
another great one.
That comes to mind. Historically, the apprenticeship way of learning at the knee of a master. Marion saying, what will the game do? So that must be a wonder. Colleen said, Mike, I have a board for my kids with Notice and Wonder where they write things down and then they share out. Christine, start and how to play buttons. Marion, I noticed the green background.
Buttons. Okay, this is a really interesting one, and it's the kind of thing that I hope is going to surface with you as my participants, and then with your students in class. So whoever said buttons, you're making an interpretation of something that you see on the screen here. Can I ask that person, what made you interpret something here as buttons?
Nice. We had a couple people talking about buttons, so whoever was talking about buttons, speak up.
They look like typical Scratch buttons.
And I think these were made by hand. This is actually a game that my daughter made a few years ago. And I think she just used some drawing, some visual conventions to make it look like a button. And sure, totally looks like that. They don't look like rectangles, they look like buttons, right? So if I were to click how to play, that would spoil the exercise here. So instead, I'm going to click start. I don't want you to know how to play. I want you to wonder, and I want you to notice. So again, in the chat, call out some things that you notice.
No timer. There's walls, color boxes, no score, blue lines, borders.
Okay, so I've heard three things there. I've heard walls, blue lines, and border that are all different interpretations of the same thing. And of course, this is what you're looking at, right? These things here. Now, if you've got some knowledge of Scratch, you might already be thinking ahead. Okay, well, these are walls. Clearly, this is a maze. You may be thinking ahead to how those were built. What's the mechanism in Scratch with which I made these? But if you don't have any Scratch experience, you're still able to get in the door here and say, well, okay, I notice walls. I don't know how those are built, but clearly they're walls. They're going to need to have some wall-like properties. And they got made somehow. So that's a really good notice. Is anybody wondering something?
I guess I'm personally wondering what's going to happen in this game. I'm excited.
Is
People
anybody
are
wondering
saying,
how high that timer goes?
oh, how much time we have to play? What am I going to do with the blocks? How do I win?
And how do I win? Let's start even more elementary than that. Here's my little player up here. I'm wondering, like, how do I do anything? Anybody have any suggestions? Because you don't have your hands on this program, I do. I need you to wander through me, and I'll try something.
Arrows?
Arrow keys. Someone suggesting WASD for.
Yeah. So I'm playing the game naively here. I'm going to start with W, A, S, D, and X, because those are often letters that are used in gaming, right? If you use your keyboard to do any computer gaming, those are very common. I just tried them, they didn't do anything. So I'm going to try next the arrow keys. Yep. I think that does what we would expect them to do. And now what else are you wondering? This is a maze. I'm going to start walking through the maze. What else are people wondering? You can just call out.
What happens if you hit the wall, border, blue line? How many times can you retry potentially?
Okay, so I just blundered into that wall and something happened. What did you notice?
Goes back to the beginning.
Yeah, did you hear a sound effect? I'm not sure if I'm sharing my audio or not.
No sound effect.
But there's a poof kind of sound effect. And then what happens when I do that? What do you notice?
It goes sound effect, and then it goes back to where it's started.
Did anybody notice that the score changes?
Yeah, people are saying that the score is going negative.
So in the interest of time, I'm going to start moving along here. Anybody wondering what happens when I hit that purple block? Is that going to do anything? Like, why is that there?
Yes, people are wondering. Okay. They're in anticipation.
Something happened there. There was another sound effect that sounded kind of lasery.
We heard one.
You did? Okay. Huh. Oh, that happened really quickly. Did you see what happened there? I'm going to wander into that block again. Oh. Okay. Have we done this enough times to interpret what that's doing?
I think so. Does anyone have any ideas? Oh, someone said teleport. Teleport to where? Random. Oh. Someone said teleport to random position.
Yeah, I like that interpretation, and we're going to go with that. So let me just finish off this maze by getting to the one thing we really haven't tried, which is that green square. Anybody have any wonderings, any guesses as to what that's going to do? Ta-da. Okay. Because we're in a maze, there's certain conventions we can expect this to follow. The purple ones are kind of mysterious. We had to try that to understand what it was. But the green as a target, like that's a pretty common color for a finish line or something like that. So, okay, we play with that. We understand. And that's basically as far as I'm going to take this routine. Okay. Now, there's been a lot of good noticings, a lot of good wonderings. And if this were how I introduced this project, and then I set you off to the computers, I want to know, on a scale of 1 to 10, how much of this do you think you could start to plan out and create? How clearly do you understand the elements that are going on here and how it works? Whether or not you have the skill to create it in Scratch, whether you know the blocks well enough or not, how well do you think you understand what we're trying to do? 1 to 10.
A few people are saying 10, which I'm guessing is like very clearly. Some people are saying very clearly. We got 7s, 9s. Someone said a little.
Yeah, so the interesting thing is, well, you know what? There was one thing I wanted to call your attention to additionally. The interesting thing here is if you've done any Scratch before, or any other programming language, you know that there are usually multiple ways to achieve any effect that you want to achieve in a program. So between your idea of what you'd like a program to do and actually achieving that, there's multiple paths you could take. There might be different kinds of instructions you could use that would achieve the same effect. That's a difficult thing for newcomers to wrap their heads around. When you're trying to master the vocabulary that the designers have given you to work with, hard to hold all of the possibilities in your head. And my own opinion is it's a good starting point to show people do this way. But the end point we want to get them to is to see different possibilities and then be able to strategize. So the one thing else that I wanted to point out here is, did you notice what's happening to the eyes of our character as we move around? That's a subtle little thing. But that's something that this designer put in there. Their eyes are tracking. And if you were to look inside this Scratch project, and Zoe, maybe you can share the URL for this project now. If I were to ask you, how is that done in Scratch? You'd say costumes. Because if you have any Scratch experience, you know that the way you change the looks of a sprite is through its costumes. So this sprite has 4 different costumes with its eyes pointing in each direction. But you might not know how that sprite is being kept upright. That's a tricky thing in Scratch, and you may have seen that in a spirograph or the cat and the ball or other projects where you've got things orienting in a direction and moving on the screen. Sprites by nature want to rotate and then point in the direction they're moving. This isn't kept that way. There are probably 5 or 6 different ways to achieve this type of movement. And the one that my daughter chose is not the one I would have chosen. She did what a programmer would call a very kludgy way of doing that. I hope that's not throwing her under the bus. Okay, so I'm going to come back to my presentation now. So the subtext, when we do a notice and wonder here, sometimes we ask this outright, is what is this program doing on the inside to make it achieve the effect we see on the outside? And I have a checklist here of different notices that I think might pop up. So let's see which ones we did. Okay, we got the title and the instructions. There's a player character and a means to control it. We have different looks. There are obstacles to move around. I didn't hear anybody notice specifically the background or the map or the level, but that's pretty obviously there. I didn't hear anybody specifically say collision detection. That's a computer science-y term, but figuring out when things have bumped into other things, and then there's rules about what needs to happen. We didn't call out a reset sequence, but going back to the beginning of the level is that. Definitely had a score and a timer. Although we didn't really do much with those, the timer just seemed to keep counting. And then we never reached the end of game condition, but there was a place at which it moved you to the next level. But I want to ask you now about the routine. So there were only a couple of people who said, yes, they've heard of Notice and Wonder, or is it See, Notice, Wonder? What are your impressions about the routine? What was the dynamic like? What did you feel this opened up for you as a participant? Did you notice there was anything I did not do? And let's back off that last one. I'd like to hear your answers in the chat. What did you feel about this routine? And then we'll move on to another one.
Do you want me to say the answers, Mike?
Please.
Okay, so we're seeing incites curiosity. Everyone has a voice and a valid response. We have collective learning, multiple entry points for all learners. People are saying that you never said no, you just elaborated more on what we said. I love that, yeah. Risk-free. Students use prior knowledge to connect. Chance to think about how it works rather than just being told how.
I love all of these. This is wonderful. Okay, so it's getting across what I'm hoping it's getting across. And here's my short list of what we feel this achieves when you open up a new unit this way. I'll just put them all on the board. So I think somebody said it starts with a level playing field, right? When we ask a question as simple as, what do you notice? And that's not meant as a trap. It's honestly, what do you notice? That's a very level playing field for people who have lots of prior knowledge and people who don't. Particularly in an area like math or programming, coding, which can be intimidating and which can feel very, very technical and closed off. This is a way of opening up access from the very first moment. Second point here is we get access to other people's thinking. This is a subtlety that I think is actually very, very powerful. Ordinarily, when you introduce a new lesson and you lead people step by step, everyone in the class gets access to your thinking because you're the one who's vocalizing and explaining and illustrating. It's rare, unless you structure your lesson to do so, that your students get access to one another's thinking. You may get access to their thinking by formative assessment or papers that they hand in, but it's rare, unless you structure it that way, for students to hear other takes, other perspectives, other ways of understanding from their peers. Now, it's very common to say, talk to your neighbor, talk to your elbow partner. It's very common to set up small groups. But this, as a whole class discussion, is a little bit different than those, and we really like it. Third point here, it helps each individual to fill in the gaps in their own understanding. And then if you're facilitating, hey, I didn't see those walls as barriers, I saw them as rectangles. Or it was only once you said that I understood the way you saw it. That kind of perspective sharing is really important, and it fills out understanding. People in the class will pick up on certain things and read more into them and interpret them more deeply than others. It's good to share that. And then where we want to pivot from just noticing and wondering to starting to build something is that once we've set that scene, all the sharing has gone on, everyone is going to have some initial strategy to start building the thing. So you no longer need to lean on step by step. Okay, so this is called sense making, right? That's the title of this talk here, sense making in coding or in computer science. So is it, just a show of hands or say yes in the chat if you've heard of sense making as a thing. I'm time checking myself, running a little bit long. Okay, sense making, is that a thing?
We're getting some yeses and nos. We got some thumbs up.
Okay, so I'm really happy to hear that sense making is something that's familiar to you. Where I've seen it in teacher conferences, I have to say that the best I've ever seen is the Ontario math community. I've been at OAME twice, and I find they, as a community, talk about sense making. In the computer science education world, it's just starting to build the idea of sense making. Sense making is our understanding of how everybody learns everything, in a sense. At a base level, anytime you're confronted with something new, you need to make sense of it. This is the constructivist way of understanding learning. And then you need to somehow fold that in, incorporate it into your mental map of concepts and how things work. So sense making in the school world is designing your instruction to make the best use of that mechanism as possible. You're teaching for conceptual understanding, and you're teaching for multiple flexible strategies. You want students to ask themselves, does this make sense? So a little bit of theory behind this. It's related to constructivism, which you may know from Piaget and Seymour Papert and others, but more particularly social constructivism. And Lev Vygotsky is one of the early researchers on this. Because in the school setting, sense making doesn't just happen in the individual's head, but sense making happens socially. We're making use of that when we do a whole class discussion. And here's a really good paper. Let me copy that link and paste it. Zoe, I forgot to give you that one. This is going to take me a moment to load the chat.
Feel free to send it to me in Scratch if it's not, or in Slack if it's not working.
Mm-hmm. Boy, that is slow. Okay, I'll carry on.
I just posted it in the chat.
Perfect, thank you. So what if sense making is our goal? Sense making, like, well, just on the face of it, yeah, of course that's the way I want to teach. But if it's just becoming a thing now, that means we probably haven't been teaching that way all along for decades. So that's sense making is often positioned against answer getting. Now, is that familiar? Answer getting develops procedural competence. I'm going to show you the steps to follow to do this thing. You'll get used to that procedure. You'll be able to mimic me. You'll be able to repeat what I'm doing. And then at the end, I'll assess you on the fidelity by which you follow that. And I'll let you know how you did. Unfortunately, that leads to very narrow, inflexible strategies. And I'm sure that's familiar to you as teachers. If you've got students who know how to follow the procedure, but don't know how to step back and understand whether it's the right procedure to use in a new situation. That's very common in the answer getting. And what students often ask themselves and they ask you is, did I do it right? That's the measuring stick for that. Okay, let's leave that conversation on the side for now. And we're going to move to another routine, just to show you that this routine, the notice and wonder, low floor way of introducing something, can move to any level of teaching coding. So we just did a Scratch maze. That's not a beginner project. That's an intermediate project, at least, because it's got so many different moving parts. Let's move now to a JavaScript project using P5.js. So this is something that you may have now seen in other people's sessions at our Summer Institute. And I'm going to ask you again, this is a text programming language, very relatable to visual arts. And I'm just going to ask you, as I noodle around here, what do you notice? And what do you wonder?
Dots following your cursor. Why are they red? I see a trail of circles. You're spilling something. Can they be another color? I wonder why the dots are different sizes. I notice that the dots are following your cursor and changing sizes.
I love the interpretations here. I'm spilling something. That's wonderful. I wonder why it's this color. Could I change it? That that's a wonder I can act on. I'm going to hit some keyboard keys indiscriminately, and I already know that no, that doesn't change. That's hard-coded in. This program is set to be this color. I'm going to leave my mouse still for a moment. Does anything happen now?
People are saying that they can still see the faded dots in the background.
So there's some kind of mechanic going on about when I move, but not when I stay still. There doesn't seem to be anything happening. There's definitely some like initial color, but then it fades, but then it always stays there. Okay. So at this point, I think we've maxed out our notices and wonders for the time being. I'm now ready to show you code. This is JavaScript using a particular library called P5. It's a version of processing. All of that doesn't matter. What I want to call your attention to is there's a setup function here. You can read that in plain English. It's creating a canvas with numbers. I could maybe assume that that's a size, or maybe that's a color. Oh no, it's not color because I can see background. And there's some numbers here. Okay, that'll tell me something about the background. I'm giving parameters to my program. And later on, I can get to the details of what those are and how to manipulate them to get the result that I want. Angle mode, degrees. Not sure what that is. It sounds technical. Frame rate. Well, I've heard that in animation and video games and so frame rate I can interpret already. I know that's like how quickly the screen's getting updated. And then I have this other function, draw. Now, knowing what I know about functions from Scratch and from elsewhere, a function is going to be a discrete thing that my program can do. And to open up this lesson and start to teach you, I could describe to you how P5 does functions. There's always going to be a draw function, and P5 is going to constantly repeat your draw function in a loop, because that's really what this platform is geared for. Scratch is geared for certain things, and microbits are geared for certain things. They're designed that way to funnel you towards a certain kind of project using a certain kind of approach by the people who made that platform. P5 is made to draw things in a loop. And so here I've got a background color. I'm filling something using a stroke. I know from experience these are codes for color. Stroke weight. And then I'm drawing a circle with some kind of parameters here. I can figure out those details later. And previous mouse X and previous mouse Y. Well, this is something to do with tracking the X and Y coordinates of my mouse pointer. And it's doing some kind of calculation that tells it how big a circle to make. I haven't yet seen the fading. That's not obvious here, but if we were to extend this lesson, I would get to how that fading is happening. Okay, so I'm going to come back to my presentation. I've talked about what's going on inside. There's functions, parameters, and variables as tools to make aesthetic choices. This is one of the wonderful things you get into when you do visual arts with code. I notice this is red fading to pink, but what I'd really love to do is, a deep purple color. I have an aesthetic choice I want to make. Well, I can't just do that. I have to learn how this code works. What are the tools that these designers have given me to work with? Is it documented well? Well, in P5's case, yes, it's documented very well. Very easy to understand. Okay, I think that's all I want to say about that. Let me step back and talk about other routines that you might be familiar with for teaching coding. Time check myself, I'm at 42. So probably the simplest way to introduce a coding lesson is the follow me approach. Now, what I have screenshotted here is a project from Code Club, which is under our umbrella, right? codeclub.ca. Maybe some of you have done Code Club activities. This is not even live taught, right? It's a document that leads someone step by step through building something. And, you can take that and as a learner and just go through it. It's almost like following IKEA instructions or Lego instructions. And the end result you're going to get is going to be pretty predictable. If you can, follow faithfully, you may have some bugs, you may miss a step or two, have to backtrack, but you'll get yourself to the end. You could then facilitate something like this. You could, as the teacher, live code through a project like this step by step and have everybody follow you. Maybe they're coding along with you, or maybe they're just watching you do it. Then you shut your screen and they do it. All of these are related to what you might know as gradual release, or I do, we do, you do, or in research it's called direct instruction. So this is certainly one way you can lead a coding lesson. And can I see a show of hands, how many people have done a coding lesson like that? Are we hearing any yeses?
There is one, couple yeses.
One yes with AstroPi.
Mm-hmm. So in my experience, and I think the team's experience, this can be hit or miss. If you've picked a project that's not at the level of your learners, it can be a white knuckle experience for them. And they're just trying to hold on and follow you until the bell rings. That's not the kind of experience we want. So we don't tend to teach this way if we can avoid it. There's another approach, which is, I've built something part way. Why don't you remix this or extend it? Take a moment to understand how this project works, what I've built so far, and then you put your own creative stamp on it, or you extend it, you take it in a direction that you like. Especially at the high school level, there's giving an assignment just with specifications. This is a project that came from an Ontario high school computer science teacher. A random numbers assignment. So what you're after here, your learning objective is to become familiar with how random numbers work. And the vehicle for that is a hangman, guessing a word project. And basically all it is I'm not going to show you how to build it, but I presume that you've been following as I've taught you the rudiments. You know all the rudiments that go into this. I'm just going to guide you to how it should work and then let you build it. That's certainly another routine you can do. But we don't tend to teach that way. And this is the story of how we came to this sense-making approach. We have experience of teaching, as Matt said the other day, sometimes more than 1,000 times in a given year, the same workshop again and again and again. And we're at a disadvantage coming into a new classroom because we don't know the prior knowledge of this class. We don't know, maybe we've had a conversation with the teacher ahead of time. That's the ideal case. But we still have to read the room and understand what these students are able to get to. And we need to improvise on the spot. And we presume that everybody who comes to us are novices. We have to presume that. And we thought that maybe some kind of routine would help scaffold both the teacher and the students to get everybody up to speed quickly, or at least level the playing field. We also hear from stakeholders that we talk to, both high school and university and industry. They all say, when we talk to them, that there's a gap in sense making. Now, that's our word, not their. I don't interpret it that way. But we hear things like when graduates come to us, they've mastered the syntax of programming language XYZ. But when we throw new problems at them, they don't know where to begin. They've got that very brittle answer-getting understanding. And then there's been some very personal experience. I was mentoring my daughter in her high school computer science a couple years ago here in Montreal. She was learning Python, and I really realized firsthand the challenge of learning a new language from scratch and doing an ambitious project, and the gap that exists. That is a gulf between, yes, I've understood the rudiments, to I know how to put them together and make them work together. And in our experience, that's more complex in computer science and coding than it is in other areas. So that's me personally. And then Matt came in, and he and I have been talking a lot about this. And we presented this together a month ago at another conference. Arts-based education has this approach too. It goes by a slightly different name, but it's essentially the same thing. You need to start with just simple perception to bring everybody in a discussing kind of way, and then you can start to build up skills. So I want to bring your attention here. So as I said, I'm on Twitter a lot. I really love to get into conversations a handful of times a year. Really good, deep conversations. I like to reflect on experiences that I have teaching, and this one attracted some attention in this little community. My message here is, this is a long thread that I put together, but the message right here is what I saw in my daughter when she was learning Python. Understanding where the project is going, for example, a hangman game. She's played a hangman game before. She knows how hangman works. She understands the rules. She can have that in one part of her brain. In the other part of her brain, she's got the rudiments of Python that she's being taught. Lists and loops and variables and conditions and all those things. She can be brought exercise by exercise to master those rudiments, but understanding how to put them together to do hangman is a really, really big gulf. I found that's where I was able to contribute to her. It was a difficult exercise. So I want to show you now a resource up with to try to facilitate this as a scaffold. So this is a worksheet that we've put on our KCJ Resources for Educators page. And Zoe, you've got the link to that. Maybe you can post that now. So we don't use this often. In fact, we were just ready to roll this out in classrooms 2 weeks before COVID hit, the very end of February 2020. So needless to say, those plans got scuttled. And what we managed to do now is the live notice and wonder, right? We do that opening routine, but at least so far, we haven't really rolled out this worksheet other than in pilots here and there. The idea behind this worksheet is we want everybody to do their computational thinking, their decomposition, their pattern recognition, their planning out algorithms together as a first step, as an adjunct to the notice and wonder routine. We've laid out on this sheet common subcomponents that go into lots of different computer programs, patterns that you see again and again. And in fact, once you reach the level of computer science and software engineering, these are called patterns. We're trying to scaffold that in-between step between, I know how a loop works. Yes, I can set up a loop. And here's how this loop is going to work inside my project. We're trying to build a scaffold in the middle on this worksheet. And that's a little bit of that notice and wonder routine was doing the same thing. You'll notice, and I'll zoom in on this in a moment, you'll notice that we're not queuing up our learners here with specific code blocks or code instructions. You won't see the word loop here. You won't see if, then, else here. Instead, you'll see more general English terms that are getting at what those codes do. And the last thing here, we're trying to separate the ideas of how my hangman program or my maze or my spilling visual arts project will work from how to build it. So as I said earlier in the Scratch routine, there are multiple ways to build each of these things. As a computer science educator, I am going to choose wider varieties of strategies rather than do it this way. If I can get my learners to a broader array of tools, I'm going to choose that. So let's zoom in and time check myself. Okay, I'm almost. Here's what's inside this project. I've got characters, moving parts, entities. I've got things that make other things happen. Now, in the Scratch world, that's like when the green flag is clicked when the space bar is pressed. In a microbit, this square does the same thing on a microbit. It's just when the A button is pressed, or the B button, or when it's shaken, or when a certain voltage is detected. Same idea. This works across multiple platforms. Information and data. Is there anything my program needs to record or remember? So that's variables, essentially. Variables, lists, arrays. I'm not calling. I want you to think metaphorically about my program needing to remember something. I have starting and restarting. Starting at the beginning of a board in a maze, or restarting an entire program from the beginning. I have changing conditions, situations, errors, problems that I need to account for and plan for. And then I have display and output. What does this program need to show my user or give back to me? That could be sounds, images, printouts, timers, that sort of thing. We've done this on an interactive digital whiteboard virtually, and it works really well. We've done it as a handout, handwritten. And what's interesting is you often get very different interpretations. For example, sound shows up here in that maze under changing conditions, but it also shows up under display and output. And that's a really good fodder for discussion to see how people interpret the same thing differently through their notices. I've got a little bit of background here. I'll skip over for the moment, but you've got resources if you'd like to look into rich or complex tasks, or 3-act tasks, or thinking classrooms. These are mostly from the math world, the sense-making approach. Matt has contributed here, some in the arts world. And then here are a handful of people who are doing sense-making in computer science, if you're interested